because, I mean, if I'm supposed to divide my pizza into 10 slices and so that I can give you 2 slices, and I decide to divide it into 9 slices and give you 2 slices, have I cheated you, or have I given you more than I should have given you? So these are things that normally would come across in day-to-day life. You also see some word problems like this in past questions. As we come up across them, I'll show you them to you. So how do we get the lowest common multiple of a number, of set of numbers like that? Like the lowest common multiple of 3 and 5 is 15. So what's going to be the lowest common multiple of 3, 4, 2, 6, and 11? That's the question. Okay. Before I talk about the lowest common multiple, I'd like to talk to you about what we call prime numbers and prime factors. I'm not going to go into details because, I mean, all we need to know is why we need them for LCM. First and foremost, a prime number is a number that can only be divided by itself and 1. No other number can conveniently go into a prime number, not even another prime number. You see? Whereas, what is funny is that every other number that is not a prime number can be represented as a product of more than one prime number, or at least one prime number. For example, a prime number will be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and it goes on. It actually goes as far as we can ever think of. 1 is not a prime number, but it's not a problem. So, do you realize something here? Numbers that are not prime numbers can be products of prime numbers. 4 is not included because it's not a prime number, but 4 is the same thing as 2 times 2. 6 is 2 times 3. 8 is 2 times 2 times 2. 9 is 3 times 3. 10 is 2 times 5. 12 is 2 times 2 times 3. Every number you can think of is a product of prime numbers. And those prime numbers are called prime factors of that number. So, a prime factor, therefore, the prime factor of a number, should I say is or are? Well, I said a prime factor, so it's going to be the prime factor of a number is that prime number that can conveniently divide through the number. For instance, 9 can be easily divided by 3 and everything is going to be fine. You're not going to have a fraction, okay? 7 is a prime number, yeah? 21 can be divided by 7 so easily. 7 is a prime factor of 21. So, how do we find this? Okay, how do we find them? Good question. Good question. Do you want to answer that, or do you want me to say it? Okay. I know most of you might have known this before, but it's something. It's worth brushing up. You see, so that at least you can always refer to them later on. How do we find the prime numbers, the prime factors of a number? And this, I'm telling you, is important in looking for lowest common multiple, and you'll see that in a bit. For instance, if I'm looking for the prime factors of 36, what do I need to do? I'm going to write 36 here, and I'm going to start dividing by likely prime numbers that can go into it. All I need to do is to look at the array of prime numbers that exist and start from the lowest one.